All of you are most welcome to Career Plus. During the series of rotational motion in NEET exam, we have already discussed part 1 and part 2, where we have discussed the questions from 2010 to 2014. Today we are going to discuss the questions of 2015. The link of part 1 and part 2 is given in the description part. All of you please go through it. Keep on watching Career Plus. Let's start the video. Given a system of three spherical cells. Spherical cell means hollow sphere of mass, each of mass small m and radius a small r. We are going to determine moment of inertia of the whole system with respect to that axis. And that axis you see, so for the first cell it is a diameter, okay, and for the second and third it's a tangent, okay. Very simple. Say moment of inertia of that cell is I1, similarly I2, I3 for that one and that one. So net moment of inertia of the system, net moment of inertia, capital I is equal to just algebraic summation of these three. এই তিনিটাৰ বীজগণিতীয় যোগফল, ঠিক আছে। সো আমি জানো যে বিয়া সাপেক্ষে এটা ফোপলা গোলক, স্ফেরিক্যাল সেল মিন্স ফোপলা গোলক, ফোপলা গোলকৰ মোমেন্ট অফ ইনার্সিয়া মই লিখাই এম আর স্কোয়ার। স্ফেরিক্যাল সেল মিন্স আগতে কলো স্ফেরিক্যাল সেল মানে ফোপলা গোলক, ঠিক আছে। গোটা গোলক হলে 2/5 হয়, সো ফোপলা হলে 2/3। সো ইউজিং প্যারালাল অ্যাক্সিস থিওরেম, সমান্তৰাল অক্ষৰ উপপাদ্য ইউজ কৰি আমি এইটো গোলক আৰু এইটো গোলকৰ কাৰণে এই যোনডাল স্পৰ্শক ই সাপেক্ষে মোমেন্ট অফ ইনার্সিয়া উলিয়াব পাৰিম। প্যারালাল অ্যাক্সিস theorem, we can write I2 is equal to moment of inertia of that cell I1 plus m r square. That means moment of inertia of that sphere with respect to diameter. So if you consider a diameter, it will be by this way, and then mass of the body into square of the distance between the two axes. So you will get the answer 2/3 m r square m r square. So therefore same for I3 also. So I2 I3 is equal to that one. So net moment of inertia I is equal to 2/3 m r square. We're just going to simplify it. So that means you'll get the answer 5, 5, 10, 12. So 12/3 m r square, 4 m r square. That's all. Next question to লৈছো আমি। কুৱেশ্যনটো এনেকুৱা, এখন টেবুলৰ ওপৰত R0 ব্যাসাৰ্ধৰ বৃত্তাকাৰ কক্ষত m ভৰৰ বস্তু এটা V0 বেগেৰে ঘূৰি আছে। এতিয়া m ভৰৰ বস্তুটো কেন্দ্ৰবিন্দুৰ পৰা এডাল তাৰেৰে আমি তলফালে টানিম। টানিলে ইয়াৰ ব্যাসাৰ্ধটো কমি গৈ তাৰ আধা হয়। দ্যাট মিন্স R0/2 ব্যাসাৰ্ধৰ বৃত্তীয় পথত ঘূৰিলে কাইনেটিক এনাৰ্জি কিমান হ'ব সেইটো উলিয়াব লাগে। এইটো আমাৰ কুৱেশ্যন, ঠিক আছে। সো ইনিশিয়েল স্টেজত তাৰ কাইনেটিক এনাৰ্জি একদম সিম্পল, হাফ m V0 স্কোয়ার। যেহেতু এটা এটা সার্কুলার মোশন, যদি বাহ্যিক বলৰ ক্ৰিয়া নাথাকে, if there is no external force, then total angular momentum of the system is conserved. That means initial angular momentum is equal to final angular momentum. So just following that theorem, initial angular momentum, that means যেতিয়া R0 ব্যাসাৰ্ধৰ বৃত্তাকাৰ কক্ষত আছিল m vr, so m v0 r0, যেতিয়া বৃত্তাকাৰ কক্ষটো আধা হৈ গ'ল, that means তাৰ ভেলোচিটি কি হ'ব, চেঞ্জ হ'ব। so m v0 dash r0 dash। so ইয়াৰ পৰা আমি কি উলিয়াই ল'ম, এতিয়া v0 dash উলিয়াই ল'ম। v0 dash আমি এইখিনি পালোঁ r0/r0 dash। এইখিনি সিম্পলিফিকেশ্যন কৰা। r0 dash মানে নাথিং এলছ, কি আছিলে r0/2। তো আমি পাম ফাইনেল ভেলোচিটি v0 dash is equal to twice v0। kinetic energy is equal to half m0 v0 dash square. So that means half m v0। next question to মই অসমীয়াত কৈ দিছোঁ চাবা। d লেন্থৰ ৰড এডাল A B দুই মূৰত দুটা এজৰ ওপৰত এনেকৈ হৰাইজণ্টেলি প্লেচ কৰা হৈছে। W weight X to the center of mass, A এজৰ পৰা চেণ্টাৰ অফ মাছৰ দূৰত্ব স্মল x, চ' বিৰ পৰা কিমান হ'ব D minus x। চ' কুৱেশ্যনটো হ'ল এট ভাৰ্টিকেল ৰিয়েকশ্যন অৰ নৰ্মেল ৰিয়েকশ্যন কিমান। সেই এট নৰ্মেল ৰিয়েকশ্যনটো আমি ধৰি ল'লোঁ N1 আৰু বিত N2। চ' এট ইকুইলিব্ৰিয়াম আমি কি ক'ব পাৰোঁ, এট ইকুইলিব্ৰিয়াম total upward force is equal to total downward force. Total downward force means weight W is equal to upward force means normal reaction N1 plus N2. We know that with respect to center of mass, total torque is balanced. That means torque on the left hand side is equal to torque on the right hand side. So that means we can write with respect to center of mass, torque is balanced. That means torque on the left hand side is equal to torque on the right hand side. Since the body is balanced, so torque on the left hand side, force into distance, that one. Similarly on the right hand side, force into distance D minus x. Since we need to determine value of N1 vertical reaction on A, so we are going to replace N2 with the help of W minus N1. So replacing N2 by W minus N1, that one. Now we are going to simplify it. Finally our answer becomes N1 is equal to that one. See the question. Particle system eta pointor eta particular position vector to দিয়া আছে আৰু হিয়া তাতে ইমান পৰিমাণৰ বলে ক্ৰিয়া কৰিছে। সো আমাক কি উলিয়াব দিছে, দ্য ভেলু অফ আলফা, ইয়াতে আলফা কিবা এটা ভেলু হয় যাৰ বাবে angular momentum about origin is conserved. So we know that if there is no torque on the system, then only angular momentum is constant or conserved. So that means torque acting on the particle must be 0. So this is the hint. So we know that tau is equal to R cross F. So very basic. So this is the cross product of the system, R cross F. So after that we are going to simplify it. Just follow the question. R 2 minus 6 minus 12 to F alpha 3 6. Simple cross product. So we are getting that term is 0, but along J and K there are some terms. Since there is no torque, J and K never become 0 because these are unit vector having value 1. So that means that one and that one must be 0. So we can write 12 plus 12 alpha is equal to 0 and 6 plus 6 alpha is equal to 0. From both the cases we are simply getting alpha is equal to minus 1. So our answer is option number C. Let's move to the next question. You see the question, what is the given parameters? There is an automobile, okay, look like wheel. So this is the wheel with respect to its own axis is rotating, okay. The radius of the wheel or automobile is given. So R is given as 0.45 meter, okay. Moment of inertia of that automobile with respect to that axis of rotation, I is also given. Moment of inertia is given as 3 kg meter square. Its initial speed is also given, VI, initial speed, say 54 kilometer per hour. 54 kilometer per hour. See, you need to determine magnitude of torque for which the wheel comes to rest. Tau is equal to I alpha. Clear? This is moment of inertia and this is angular acceleration. And again divided by the time of acting. So again the time of acting also given. At how much time it becomes 0? At 15 seconds. Clear? Now step by step we are going to determine omega I and omega F, okay. omega I, initial angular velocity, taking the SI, okay. So VI is equal to, we are getting 54 kilometer per hour. We have to convert it into meter per second. Answer 15 meter per second. Clear? Now step by step, omega I becomes 100 by 3 radian per second. It becomes omega I. And what is the value of omega f? This final angular velocity will becomes raised to 0 radian per second. Clear? So therefore we are getting alpha is equal to second. So we are getting the value look like that. Say suppose minus 100 by 45 radian per second square. Clear? So therefore the magnitude of torque 0.66 kg meter square per second. This is the last question of 2015. Things are look like that. The 2 point masses M1 M2 attached with the help of that rod of length capital L. Consider one vertical axis. We need to determine the position of this vertical axis from mass M1 with respect to which the rod can rotate with minimum angular speed omega naught. Clear? Okay. This is the question. Let's start. So you know the moment of inertia of the system about the axis of rotation through the point P. Say this is point P. Moment of inertia of the system, simply we can get I is equal to mass into distance square. Mass m1 here to here x, so mx square plus same way m2 that distance L minus x square. This is the moment of inertia of the system with respect to that rotating axis. Clear? Now it's just simply using work energy theorem. We know amount of work done, simply I'm going to write amount of work done is equal to total rotational kinetic energy. So therefore we know work done W is equal to rotational kinetic energy half I omega square. So during that case omega naught is given. Simply put the value of I for minimum angular velocity. We can write to be minimum it becomes constant value, so work done becomes 0. That's simple derivation. Just simply derive it. Since omega naught is not equal to 0, then definitely that part will become 0. So after that we will get that one m1. So therefore x equal to, we are getting that one. This is the answer. Answer coming look like that, option B. Clear? আশা কৰোঁ আটাইকেইটা নিউমাৰিকেল ঠিকমতে বুজি পাইছা। ভিডিঅ'টো শ্বেয়াৰ কৰিবা বুলি আশা কৰিলোঁ আৰু লগতে আমাৰ চেনেলটো ছাবস্ক্ৰাইব কৰিবা যাতে পৰৱৰ্তী ভিডিঅ'সমূহৰ ন'টিফিকেশ্যনটো সোনকালে গম পাই যোৱা। Keep on watching Career Plus for next videos of rotational motion in NEET exam.